Hi guys, so I'm gonna do the video officially for 1C. The video that I posted previously, it was actually for the sections for the summary lesson of 2C. So this is what the original exercise looks like. I'll do about 3 questions. So I'll scroll down. I posted a solution for this, but I'll do it live as well for question 3. It says that this girl throws a rock off of a cliff. You have this expression that describes the height with respect to time, and then they have all of those follow-up questions. So I have them here on the board. I'm gonna do A and B algebraically, and then for part C, they want us to use a graphing calculator to just check the work, and then I'll go through the concept with respect to that. So let's start off with the first one. I'll just get set up. So when they're asking for the initial height of where this rock is supposed to be, if we were to draw a picture, we know that this parabola would be opening down just because you have your a value here is negative. And then if you remember that if it's in standard form, this would give us the y-intercept. So if they want the initial height, when I look at a parabola that's opening down and she's throwing the rock off of a cliff, it makes sense that in my picture, she's starting at a height somewhere here, and then she's gonna throw the rock. So maybe she does it like this, and then the rock is going to land somewhere like that. So this is your time or x-axis, and this is your height, and this is your y-axis. So when they ask for the initial height, this is the value that we're actually looking for. And in terms of a characteristic, this would be the h-intercept. This would technically also be the y-intercept. And so for over here, anytime that we want to find a y-intercept or an h-intercept, we would say that we're going to let t or x be equal to 0 because t or x is equal to 0 would be at this line over here. So let's make that substitution. So we're going to say let time in this case, or we would write x is equal to 0, and then substitute that into our expression here. So the height, anywhere that I see t, I'm going to replace it with 0. And then algebraically, you've seen this before, that the first term, because I'm multiplying by this 0, it's going to be resulting to 0. The second term is also being multiplied by 0. So the second term would also be 0. And we're left with this last number at the end that would identify the y-intercept or the initial height in this case. So again, this becomes 0. So we can kind of cross this out. Maybe I'll do it a different color. So this term goes to 0. This term will also go to 0, and then we're left with this. So the height, when time is equal to 0, is going to be equal to 210 meters. Okay, so we would write, therefore, initial height. Jessica's initial height is at 210 meters. Okay. And then for part B, they're asking what is going to be the height of the rock at 3 seconds. So we're still looking at this same expression. We're now looking at, instead of it being at 0, this one's a little bit easier, that they want to find the height at actually 3 seconds. So instead of substituting 0, we're going to substitute t is equal to 3 there. So let's try that again. So we're going to say let the time be at 3 seconds. Then we'll make the substitution in this equation. So let's do the height is equal to negative 4.9. We're going to write 3 squared. Then we're going to add 10.2, multiply this by 3, and then we're going to add 210. So then we're going to just perform BEDMAS. So 3 squared is going to give us the 9. We're going to multiply that by negative 4.9. We're going to add this over here, this product. So 10 times 3 is 30. If we're multiplying 0.2 by 3, this will be 0.6. And then we're adding the 210. Then I'm going to use a calculator to simplify this. I'll just go here. You guys hopefully are doing it with me as well. So I'm going to have negative 4.9. I'm multiplying this by 9. And then I'm adding 30.6. And then I'm going to add 210. And then they give me an answer of 196.5 meters. Okay. So the height at 3 seconds would be 196.5 meters. And then for part C, they want us to use a graphing calculator to find the maximum height. And for that characteristic, if this is a quadratic function, so I know it's going to be in the shape of a parabola, the maximum height would be the point of where the vertex is actually going to be. So you have your techniques that you would want to find your vertex. You have those shortcuts that I showed you that you can find the axis of symmetry, which is negative b over 2a. So you need this value for the b, and this is your value going to be for a. And then you would find the corresponding y value to get the coordinates of the vertex. Okay. And then this one, the time to hit the ground. So this is essentially this point. And this point over here, you would want to find the x-intercepts. So for here, we would factor it if it was factorable, which it should be. We would also use the quadratic formula. We'll do that later on in the lessons. So again, we can add here that we would use the quadratic formula. But let's just practice using Desmos to confirm these answers. So let me plot this expression here, and let's confirm all of our previous answers before. So on Desmos, I'm going to write the function negative 4.9. They're using t, I'm just going to use x squared. And then we're adding 10.2 x. And then we're adding the 210. So when I look at this parabola, yes, it's opening down. We're happy about that. It's a little bit obviously narrow because of the 4.9 that it's being multiplied by. If I check these points that they wanted, the vertex is located here. So this would be the vertex that you would calculate. So we would conclude that the maximum height would be this 215.3 meters. Here's our initial height or our initial value that we calculated at 210. And here, when the ball is going to get dropped on the ground, so here we have the ball that takes off and it's going to fall all the way down from the cliff. We would look at that x-intercept, which would be right here. So we would conclude that it's at 7.67 seconds when the rock gets hits the ground. And then that other answer that we should confirm is that when the height is actually equal to 3, or sorry, at 3 seconds, so when we write x is equal to 3, we want to see where this line intersects, and it should be at that value that we calculated before. So here we have 196, which matches our calculation or our math from above. Okay, thanks.